This is E-Demonstration System of Asset Administration Shell, AAS, based plug and produce PnP in smart manufacturing, co-developed by Nestfield Ltd. and Hanyang University. In the era of Industry 4.0, one of the key challenges is how to digitalize the industrial production. The Asset Administration Shell is designed to transform the asset from a physical world into a digital world. What is Asset Administration Shell? It is a virtual representation of all the information and functionalities of an asset. It provides a standardized communication interface for information exchange. It is an access point of information and value-added functions in Industry 4.0. Why is Asset Administration Shell needed? The purpose of Asset Administration Shell is to facilitate the exchange of asset-related data along the production system life cycle. The Asset Administration Shell will make all the manufacturing components interoperable to realize the autonomy of Industry 4.0. Adaptable Factory envisions a flexible factory where production lines can be reconfigured during runtime. Analogs to the plug-and-play concept for desktop computers. The vision of plug-and-produce use case is to enable plug-and-produce capabilities for future production facilities. Compared to today's traditional production, plug-and-produce makes a new production paradigm possible. If there is an error with the working robot, the production line will stop. Therefore, on-site operator will immediately plug out the error robot and plug in a new robot, which will connect to the production system and perform the same tasks. That is, new field devices, or production modules, shall be integrated into production lines with minimal overhead, thus greatly increasing the production flexibility. The AAS-based PnP demo system has a 3-layer architecture. The top decision-making layer controls the whole system running using a web UI. The middle AAS layer is the AAS platform supporting AAS information exchange. The field asset layer contains 3 type-independent industrial robots and 1 turntable. This is the demo for showing AAS, Asset Administration Shell-based plug and produce in smart manufacturing. AAS plays the same role as the digital twin in smart manufacturing. Key characteristics of this AAS-based PnP system are threefold. First, each asset, for example, robots and turntable, has a unique AAS. Second, asset information are digitally represented in the AAS. Third, AAS can communicate with each other to realize the PnP function. AAS is composed of Digital Factory Header, DF Header, Digital Factory Body, DF Body, and submodels. AAS is now under development as an international standard in IEC Project 63278. Asset information are stored as properties in the AAS submodels, and the AAS has a communication interface to exchange data with other AASs. This is the information model of the AAS for KUKA robot. The DF header contains basic AAS information, for example, identification of asset and identification of AAS. The ID is in a format of Global Unified Identifier. The DF body contains 5 submodels. They are 1. Index data item, 2. Property value statement. 3. Documentation. 4. Communication. 5. Pick and place. The pick and place submodel is an asset-specific submodel, which is designed for KUKA Robot to store and exchange pick and place related process data. How to implement the AAS? First, we use Automation ML, standardized in IEC 62714, to model AAS information of the PnP system. Automation ML is an XML-based data format that is suitable for describing information in AAS submodels. Automation ML contains an instant hierarchy module, hierarchically modeling individual objects as internal elements. Second, we use OPC UA, standardized in IEC 62541, as the communication interface to exchange data between AASs. OPC UA is a machine-to-machine communication method, providing interfaces for data exchange between industrial assets. We adopt OPC UA client-server mode to realize the communication capability of AAS. By utilizing Automation ML and OPC UA, AAS realizes the PnP capability in Industry 4.0. The turntable is surrounded by 3 robots, designated as R1, Epson 1 robot, R2, Epson 2 robot, and R3, KUKA robot. The web UI controls the system operating in operation mode and PnP mode separately. When an operation strategy is chosen on Web UI, the system will run in an operation mode. First, click the drop-down menu to choose 2 robots, for example, Epson 1 robot and KUKA robot, to operate in the operation mode. Afterwards, Epson 1 robot and KUKA robot are executing the pick and place task on the turntable in an operation mode. Indicator lights of Epson 1 robot and KUKA robot are green, while the indicator light of the Epson 2 robot is red. Finally, real-time AAS data of robots and turntable are monitored on the Web UI real system. Operation is synchronized with the virtual animation on the Web UI. In order to let the system run in a PnP mode, click the PnP drop-down menu on Web UI to choose a PnP strategy. For example, plug out one running robot, for example, Epson 1 robot, and plug in the third idle robot, for example, Epson 2 robot, to proceed with the pick and place task. At this time, all indicator lights of the 3 robots turn to yellow, indicating the PnP configuration process among 3 robots and turntable. During this process, AAS of robots and turntable will communicate to determine the operation of corresponding assets. Now, KUKA robot and Epson 1 robot are working in an operation mode. Now, through PnP mode operation plugout, the Epson 1 robot plug in Epson 2 robot. Now Epson 1 robot is plugged out, Epson 2 robot and KUKA robot are executing the pick and place task on the turntable in a PnP mode. Finally, real-time AAS data of robots and turntable in the PnP mode are monitored on the Web UI. Real system operation in the PnP mode is synchronized with the virtual animation on the Web UI. In order to change the system to run in another PnP mode, click the PnP drop-down menu on Web UI to choose another PnP strategy. For example, plug out another running robot, the KUKA robot, and plug in the third idle robot, the Epson 1 robot, to proceed with the pick and place task. At this time, all indicator lights of the 3 robots turn to yellow, indicating the PnP configuration process among 3 robots and turntable. During this process, AAS of robots and turntable will communicate to determine the operation of corresponding assets. Epson 2 robot's status light, it turns green to signify movement. Now KUKA robot is plugged out. Epson 1 robot and Epson 2 robot are executing the pick and place task on the turntable in a PnP mode. The figure shows the sequence diagram illustrating the information flows among AASs. Following the diagram, robots and turntable can operate in accordance with the chosen PnP strategy. Initially, R1, R2, and turntable are operating in an operation mode. When a PnP strategy is selected on the web UI, it will be delivered into all the AASs in the AAS platform. AAS of R1 will send its current status information of AAS of turntable, R2, and R3 sequentially. And AAS of R3 will order R3 not to operate anymore. After everything is confirmed, the PnP mode ends and the PnP strategy is carried out successfully. Finally, the AAS platform will feed updated information of all involved AASs back for showing on the web UI.